Okay, so this is our third video in the circular functions series, and I should have mentioned earlier that one of the things about circular functions is that there are a number of sort of definitional, seemingly relatively minor things that we need to gradually build up and learn before we can actually get to the point of being able to solve an equation or sketch a graph. Okay, so these early videos really are establishing all those background skills, and then when we come to solving an equation, we really need to be able to put all of that together all at once. Okay, so whilst each thing on its own seems relatively trivial, it will all come together magically for you a little bit down the track. So as I mentioned to you in the earlier videos, we revised the use of the trig ratios in right-angled triangles in our previous video. But I talked about the fact that we're going to go back to basics in terms of actually the definitions of sine and cosine and tangent, okay? And they're not, sine is not defined as being the opposite side length over the hypotenuse. The definitions come from something more basic, and then sqrt is a result of those earlier definitions. So the definitions of sine and cosine and tangent, which I'll deal with a bit separately further down the page here, all come from the unit circle. So remember we talked about the unit circle back when we defined degrees and radians. So a circle with a radius of 1, so that would make, and the centre at the origin, so that would make this the point 1, 0, this the point 0, 1, this the point negative 1, 0, and this the point 0, negative 1. Okay, so in the unit circle, one thing we need to talk about before we get on to the definitions is when we measure an angle in the unit circle, we have a consistent and predefined way in which we talk about angles in the unit circle. And we always measure angles in the unit circle relative to the positive x-axis. So by that I mean this. So relative to the positive x-axis in an anti-clockwise direction. So heading around this way. Okay, so if we want to talk about an angle of 30 degrees in the unit circle, we would be going 30 degrees up here. If we want to talk about an angle of 90 degrees in the unit circle, that would be up here at the y-axis. If we want to talk about an angle of 100 degrees, we'd be going past the y-axis around here into what we call the second quadrant. So when we talk about the unit circle, it's divided into 4 quadrants by the axes. This is the first quadrant. This is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, so, and we measure angles relative to the positive x-axis. So we could go round to 200 degrees, round into the third quadrant. We could go round to 300 degrees, round in the fourth quadrant. We can also go backwards. We can talk about negative 30 degrees, for example, going this way. We could lap around more than once. We could talk about 400 degrees, being back around here in the first quadrant. Okay, so always measuring our angles relative to the positive x-axis in an anti-clockwise direction. That's the first thing we need to understand. So sine of theta is defined as the y-coordinate of the point on the unit circle, so on the circumference of the unit circle, that should probably say, that is at an angle of theta. Okay, so, and we're talking in radians because there's no units on the theta. But we could measure in degrees in the unit circle. We can do both in the circle. So when we turn an angle of theta degrees in the unit circle, we extend out to the circumference of the circle, the y-coordinate of that point is equal to sine of that angle. Okay, the x-coordinate of that point is equal to the cosine of that angle. Okay, so I'm just going to pause the video here. I'm just going to switch over to a different program for a minute so we can sort of explore those definitions a little bit further. Okay, so here we have our unit circle. Now I can't draw in this package, so you're going to need to keep an eye on my moving cursor to see where I'm pointing. And I'm sorry that it's white. So what we have here is the unit circle. Okay, we've got a point on the circumference of the unit circle that at the moment, if we talk about how we measure angles in the unit circle, is at an angle of 0 degrees. Let's talk about degrees while we're familiar with that for a minute. 0 degrees. And so we can see that the x-coordinate of the point here is 1. okay, and the x-coordinate corresponds to the cosine value. So cos of 0 is equal to 1. That's exactly what this tells us. Sine of 0 is the y-coordinate at an angle of 0. That's equal to 0. You can confirm that by typing those things into your CAS. Typing cos of 0, you'll get 1. Typing sine of 0, you'll get 0. Then what we can see is, as we move this point, so we change the angle, obviously the coordinates of the point on the circumference of the circle are changing as well. So say, for example, we can stop anywhere we want. Let's say here around 41 degrees, okay? So sine of 41 degrees is the y-coordinate at this point, 0.66. And obviously we're working in rounded decimals here, but just giving you a sense of what's happening. Cos of about 41 degrees is approximately 0.76. Again, you could try typing those values into your CAS and you would find that it would give you the same thing. In fact, let me check that. I'll get my CAS here. Sorry, let me just resize it in this window so that you can see it fully. Alright, I think we're in there now. Okay, so if I type in here, I'm in degree mode, which is good. My angle's been measured in degrees here. So sine of, okay, let's be precise here, 40.97 degrees. We would expect to be equal to approximately 0.66. Yep, rounded to 2 decimal places, that is 0.66. Okay. Cosine of 40.97. Control Enter for decimal. Is indeed, again to 2 decimal places, 0.76. Okay. And you should be able to check that for any value as I move around the circle. I'll just get rid of that for a minute. Okay, so again, as we see, we're increasing the size of the angle. Clearly the cosine value, which is the x-coordinate, is getting smaller. It started out being 1 here. It's clearly getting smaller. So here it is 0.82. Cos of 34.84 is 0.82. Cos of 66.38 is 0.4. Cos of 80.68 is 0.16. Getting smaller and smaller until here at cos of 90 degrees, cos of 90 degrees will be 0. And again, you could check that by typing that into your CAS. So through the first quadrant, we see cos gets smaller, but cos gets bigger. Cos, the x value gets smaller. Sine, which is the y value, is clearly getting bigger. So here the y-coordinate is 0 at an angle of 0. Sorry, just to get where we are here. And then as we increase the angle, the value of sine is also increasing. So for example here, sine of 32.24 is 0.53. Sine of 56.24 is 0.83. Sine of 77.3 is 0.98. So it's getting bigger and bigger until it gets to its biggest value here, which is 1. Sine of 90 degrees, sorry, let me see if I can get that to give you 90 again. Not quite. But sine of 90 degrees is 1. And then as we move around into the second quadrant, let's think about what's going to happen. Okay, well actually, if I think about my sine values are still going to stay positive, but the x-coordinates around here are negative. And you try it. Let me get my CAS up again. So if I type in, sorry, there it is there. If I type in cos of an angle that's bigger than 90 degrees, I should get, so let's say cos of 100 degrees, it'll be a negative value. That's because the x-coordinate is negative at an angle of 100. If I look at this corresponding value here, cosine of 128.53 degrees is indeed negative 0.62 to 2 decimal places. Sine, however, around here, because it's y-coordinates and the y-coordinates in the second quadrant are positive, and we'll talk more about this in the next video, sine at this value, it's not sine of 0.78, let's delete that. Sine at 128.53, I wrote 56, sorry, close enough, is also 0.78. And then we can continue, we can go around into the third quadrant where we'll see sine and cosine values are both negative. So in this case, sine of 221.03 is the x-coordinate, sorry, is the y-coordinate, so it's negative 0.66. Cosine of 221.03 is also negative 0.75. We can go around into the fourth quadrant here, where the cosine values, the x-coordinates will become positive, and the y-coordinates, the sine values, are negative. So for example here, we're seeing that cosine of 322.6 is 0.79, cosine of 322.6 is 0.61. So this is the definition of sine and cos. I'll talk about tan in a minute and we'll come back to this unit circle. sine and cos in the unit circle. So as we change the angle, the value of sine and cos is changing. It corresponds to the coordinates of the point on the circumference of the unit circle. The x coordinate being cos of the angle and the y coordinate being sine of the angle. Okay. As I said earlier, we can go round past 360 degrees. This graphing program won't let me show you that. If I go past here, it'll go back to being a small angle here. But for example, cos of 380 degrees, which would be equivalent to being here at 20, so somewhere around there, is going to be cos of 380 degrees, which is 360 plus another 20, would be 0.94, for example. Okay, and we can lap around as often as we want. Okay, I'm going to go back to the notes for a moment. Okay, so over in the graphing package, we had a play around with sine and cosine in the unit circle. So cosine corresponding to the x coordinate of the point at an angle of theta in the unit circle, and sine theta corresponding to the y coordinate. Let's now have a look at tan, and then we'll go back over to the graphing program. So tan theta is defined as the y coordinate of the point where the line at an angle of theta meets with the tangent to the unit circle at the point 1, 0. Okay, so the tangent to the unit circle at the point 1, 0, this is the tangent here, this line here. It's in fact the line x equals 1, okay, is tangent to the unit circle at that point 1, 0. And the value of tan, which is why it's called tan being short for tangent, is the y coordinate of this point. Now, it's not the x coordinate. The x coordinate is obviously 1. It's the line x equals 1. But the y coordinate of that point gives us tan of theta. Okay, so tan of that angle is equal to the y coordinate of that point. And we'll go over to the graphing package to explore what happens as we move into the second and third quadrants with tan. You'll be able to see that much better as I can move the points around the circle. Okay, so we've come back to our unit circle here, and this time I've added in the tangent at the point 1, 0, and I've also extended out the line, which did just go from the centre of the circle to the circumference. I've extended that right through the circle so that we can see clearly what happens as we move around the circle. So we've still got the point here on the circumference, which obviously corresponds to the cosine value for the x coordinate and the sine value for the y coordinate. So here we're seeing that cosine of 49.72 is 0.65 and sine of 49.72 is 0.76. What we're now also seeing by extending out to meet with this tangent is that tan of 49.72 is 1.18. And again, we should be able to confirm that with our CAS. Let me just delete some of these calculations. So we should be able to confirm that tan of 49.72 is 1.18 to 2 decimal places. So obviously when tan is 0, when the angle is 0, tan will also be 0. And then as the angle increases, tan gets bigger. So here we're looking at the blue point, sorry, I know they're overlapping, but tan of 23.5 is 0.43. And the difference with tan is, where sine and cos are bounded by the circle, because tan's on this tangent, tan can get very big. Okay, so for example, when tan's up here close to 90 degrees, the value of, when the angle's up here close to 90 degrees, tan is a very, very big value. Okay, so for example, here, if we have a look at tan of 85.19, oops, 0.19, sorry, we see that tan is at 11.88, so almost 12, so which is quite big compared to the scale that we're seeing here. It could obviously get infinitely big. If we make tan a really big value, so I mean by really big I mean very, very close to 90 degrees, so if we go with 89.999999, now that is an enormous number. And so tan gets bigger and bigger and bigger until at 90 degrees, that blue line is now never going to meet with the tangent. So if we were to type into our calculator tan of 90 degrees, our CAS will tell us that it's undefined, which makes perfect sense given the definition we've got here. Now, when we move around into the next quadrant, let me just move my CAS for a minute. When I move around into the second quadrant, the value of tan now corresponds with, so where that blue line is intersecting with the tangent is now a very big negative number. You'll see what I mean as I move this up. You'll see the point that I'm talking about. There it is there, okay? So here, tan of 122.54 is negative 1.57. So up here when tan was just a little bit more than 90 degrees, tan was a very large negative number, okay? So then tan, it's negative, but it's getting smaller and smaller. Again, around here at 180 degrees, the value of tan will again be 0. Then round in the third quadrant, we're back up to the same thing that was happening in the first quadrant. Okay, so when tan is equal to 213.69, let me see if I can make this sort of an angle. Let's say that's 210 for example's sake. So if we're talking about tan of 210 degrees, it's approximately 0.58. Okay, now 210 is 30 degrees past 180. So what we're actually seeing here, if we think about the symmetry, now you just have to look at where I'm moving the mouse. I'm sorry, I can't draw here. This angle in here is the same as this angle down here. So 210 degrees is 30 degrees past 180. And so that's going to mean it's 30 degrees up here. So what we would find is that tan of 210 should be exactly the same as tan of 30. And again, we can get our CAS to confirm that for us. So tan of 210 should be around about 0.58. Yep. Should be the same as tan of 30, which is the same value, about 0.58. Okay, we'll talk more. So there's a lot of symmetry that happens in the unit circle. We'll talk more about that in the next video, but I think it's important that you get the sense of that from the definitions. And then around here in the fourth quadrant, obviously the tan value is down there negative again. So, you know, tan of 306.51 degrees is negative 1.35. Okay, so there's our definitions of sine and cos and tan in the unit circle. Let's go back to the notes. Okay, so we're returning here. We've now defined sine, cosine, and tangent. We understand this little note down here that in the unit circle, the angle theta is always measured in an anti-clockwise direction from the positive x-axis. So that's where sine, cosine, and tangent come from. Okay, so let's have a look at a couple of examples here. So for each of the following angles, now we've talked only in degrees so far. So let's think about now our unit circle and think a little bit in radians. Okay, so for each of the following angles, theta, determine the values of sine theta, cos theta, and tan theta. Okay, I'm going to draw a unit circle off to the side here. So we have our unit circle. You'll be drawing a lot of these throughout this topic. We don't really need X there. Okay, so let's think about what's happening here. Let's start to think in radians. So we know 0 degrees is 0 radians. So remember, the key is that 180 degrees is the same as pi radians. So around here at 180 degrees, this will be pi radians. And then around here back at 360 degrees will be 2 pi radians. Okay. So therefore, this angle up here at 90 degrees, that's obviously half of 180, or half of pi. Pi on 2 radians. Around here, now let's think a bit about that. I mean, you could think about halves of pi. So this is 1/2 of pi, 2 halves of pi, 3 halves of pi. Okay, 3 lots of 90 degrees, 3 lots of pi on 2. You could think about it as being 1.5 times 180 degrees. However you want to do it, this position around here in the unit circle, that angle is 3 pi on 2. Okay, so I've written the angles at the points, but they're not anything to do with the coordinates of the points. Okay, the angle all the way around here is 3 pi on 2. The angle from here to here is pi. The angle from here to here is pi on 2. Okay, the angle from here all the way around here is 2 pi. Okay, so the coordinates of those points, so let's add those on because they're going to be important in this as well. That's 0, -1. That's 1, 0. That's 0, 1. And that is -1, 0. Okay, so let's think about the questions that we're being asked here. So the first one is to find the values of sine theta, cos theta, and tan theta if theta is 0. So if we're at an angle of 0 degrees. So if we're here, The value of sine theta is the y-coordinate of that point, so 0. The value of cos theta is the x-coordinate of that point, so 1. And the value of tan theta is, now let me draw in my tangent, is the y-coordinate of that point, which is 0. Okay. Alright, so let's note that over here. Oops, sorry. So sine of theta is the y-coordinate of the point at an angle of theta, that is 0. Cosine of theta, the x-coordinate of a point of the point, sorry, it's not theta, let's make it 0 now. Sine of 0 is 0. Cos of 0, the x-coordinate at an angle of 0 is 1. And tan of 0, the y-coordinate on the tangent, sorry, habit to write theta, the y-coordinate on the tangent at an angle of 0 is also 0. Okay, then we want to think about pi on 2. So in our unit circle, we've thought about pi on 2 is half of pi, which is half of 180 degrees, so 90 degrees. So we're at the top there at the point 0, 1. And so therefore, sine of pi on 2, which is the same as pi on 90 degrees, is the y-coordinate that's at this point, which is 1. Cosine of pi on 2 is the x-coordinate at this point, which is 0. Tan of pi on 2, we explored that in the graphing package earlier. The tangent will never meet with this line here, that's undefined. Okay, let's think about 3 pi. So now we've gone past our unit circle, so let's think about where would 3 pi be. So pi is 180 degrees, so that's pi. That's 2 pi to continue around to there, which means it would be 3 pi to go all the way around back again to here. So 3 pi is the same position in the unit circle as pi. So we're interested in this point here at negative 1, 0. Okay. So we're looking at the value of, trying to get that unit circle so you can see it as well. Sine at 3 pi, so the y-coordinate at this point is 0. Cosine at 3 pi, the x-coordinate at this point is negative 1. And tan at 3 pi. Now remember, when we're around here, on the x-axis here, let me just get a larger pen so you can see what I'm drawing. Here we extend the line the whole way through the circle, so we're actually talking about that point over there at 1, 0. So the y-coordinate at that point is 0. Okay, let's go back here. Alright, theta of negative 52 pi. So let's think about what's happening here. Let me just move around the unit circle. I'm just going to make a mess of our circle for a minute. Okay, so we already looked at, as we move around the circle, this is pi, this is 2 pi, this is 3 pi, this is 4 pi, this is 5 pi, this is 6 pi, this is 7 pi. You have odd multiples of pi happening over here, and you have even multiples of pi happening over here. So therefore, negative 52 pi, and that would be the same if we went in the other direction. We've just got a negative. So that would be the same if we went the other way. This would be negative pi, negative 180 degrees, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi. So we've got the odd multiples of pi, whether they're positive or negative, on the left-hand side, and the even multiples of pi on the right-hand side. Okay, so if we've got negative 52 pi, we don't need to count all the way around. We know that's going to happen over here at the point 1, 0. And so therefore, the sine value here, the y-coordinate here, is 0. The cosine value here, 52, is 1. And the tan value here is also 0. Okay, let's have a look at the next couple. Sorry, I'm just trying to give us some space in our circle. 990 degrees, so all of a sudden we're thinking in degrees. Alright, let's think about what that would be. So, it's 3 lots of 330, so it's not 3 lots of 360. How many lots of 90? It's 11 lots of 90. Yeah? So 11 lots of 90 degrees. So again, let's think in our unit circle where that would be. Sorry, just let me get us a pen that we can draw with. 11 lots of 90 degrees. So that's 1 lot of 90 degrees, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be 990 degrees around here at the point 0, -1, and so therefore sine of 990 degrees is the y-coordinate at that point, which is -1. Cosine of 990 degrees is the x-coordinate at that point, which is 0. And tan is going to be undefined. Sorry, so tan doesn't exist on its own. Tan of 990 degrees is undefined. Alright, last one, let's think about -7 pi on 2. Okay, so negative meaning we're going in a clockwise direction around the unit circle, and it's 7 lots of pi on 2. Okay, so 7 lots of pi on 2. There's 1 lot of pi on 2, 2, 3, 4, 5, 6, 7. So around here at pi on 2, sorry, at the same point as pi on 2, but at the point of 0, 1. So therefore sine of -7 pi on 2 is the y-coordinate at that point, which is 1. Cosine of -7 pi on 2 is the x-coordinate at that point, which is 0. And tan of -7 pi on 2, again we've got this issue with it being parallel to the tangent, and so it is undefined. Okay, so just starting to explore the unit circle, thinking in both degrees and radians, and understanding our definitions of sine, cos and tan. The last example I want to talk through is we need to, before we get to that, to look at connecting sine and cos and tan. So in our unit circle, when we think about our definition of sine and cos and tan, let me erase some of this here, we have two similar triangles happening here, okay? We have this triangle here, where that is sine theta there, and this is cos theta. And then we have the larger one, that one, where that length there is tan of theta, and that length there is 1. Obviously, the radius of the pink triangle, the hypotenuse of the pink triangle is the radius of the circle, which is 1. So you've got two similar triangles here. They both have an angle of theta, and they both have a right angle, so all three angles are the same, and therefore they're similar. So these are two similar triangles that come out of that definition in the unit circle. So if we have a think about what's happening here, we can create some relationships. And similarity is actually where SQRT comes from. We can go into that at another time. But we can create a relationship here between sine, cos, and tan using similarity. So we know similar triangles, side lengths are in the same ratio. So if I was to do tan of theta, that, divided by that, that's going to be the same as if I did sine of theta divided by cos of theta. You can create some other kind of version of that same ratio, but essentially dividing corresponding side lengths is going to are going to be equal because we have similar triangles. So the side lengths are all in the same proportion. And so therefore what we get from here is a relationship between sine and tan and cos and tan. So tan of theta is equal to sine of theta over cos of theta. And we should be able to check that. If we have a look at, let's just put some values in the CAS over here. Let's have a look at sine of 30. I'm going to leave it exactly, so it'll give it to me if I can. And then cos of 30 involves a surd, but that's okay. It's exactly equal to root 3 on 2. We'll talk more about how we can obtain these exact values in a couple of videos' time. And then if we calculate tan of 30, it should be the same as sine of 30 divided by cos of 30. Okay, so let's have a think first of all before I calculate tan of 30. Let's work out what sine of 30 divided by cos of 30 is. It's root 3 on 3. Okay, so now let's work out tan of 30. It is indeed root 3 on 3. And obviously I've only shown that for one particular value, but this is true for any angle. Okay, so example 2, if, I've actually given you the numbers that we just worked with in the CAS in the example, my apologies. So if cos of theta is equal to 1/2 and sine of theta is equal to root 3 on 2, find the value of tan of theta. So what this isn't asking you to do is find theta. Okay, so we don't need your CAS at all for this question. So what we know is that tan of theta is equal to sine of theta divided by cos of theta. So in this case, sine of theta is equal to 1/2 divided by cos of theta, which is equal to root 3 on 2. Okay, So what we have here is 1/2 divided by root 3 on 2, which is the same as 1/2 multiplied by 2 on root 3. So our 2's cancel out and we get 1 on root 3. It doesn't quite match what our CAS told us, but if we were to rationalise this fraction, rationalise the denominator here, we would indeed get root 3 on 3. Okay, so they're the same thing. You don't need to rationalise the denominator, it's just that your CAS does, so just to show you they're the same thing. So we get this really important connection between sine theta, cos theta and tan theta, which is handy in a number of instances, so we just raised that here. But essentially we want to focus on the definition of sine and cos and tan in your unit circle and how you work with that. The next video I'll explore a bit more the symmetries that we started to see as we played around in the unit circle earlier.